one of the issues is, well, I want to present what we call Deontic argumentation. So argumentation is about how to argue, and then essentially, well, typically in legal reasoning, it's you want to reason, and typically you want to reason with some concepts which are deontic, so obligation, permission, and similar concepts. And while argumentation has been developed originally, and a good part of the development of argumentation originated from, let's say, AI and law, very few approaches consider deontic argumentation. And so here we want to correct the issue. Okay, so like what I said, we have to consider how to reason with deontic argument. In particular, we will consider the notion of with permission. So essentially today I'm going to introduce what we mean by with permissions, what are the properties with permissions, and I will give, well, I will have a crash introduction to what argumentation, and we're going to see, well, the standard or some of the standard argumentation semantics, and then in the first part, we are going to see that standard argumentation semantics have big problems because we will see they're not able to capture some particular notion, in particular the notion of permission. And then in the second part, we see how to rectify, and I'm going to propose a novel semantics, a novel argumentation semantics to capture with permission. Okay, now first of all, we have to consider permission, and essentially for permissions, we have to define what permission is, and then in particular, we wanted to distinguish two notions of permission. We are going to consider the distinction between explicit permission versus implicit permission. And then, well, when we consider, let's say, legal documents, legal text, and norms, then essentially we can consider that, well, those norms, they can model different things, they can represent and they can prescribe different things. And then in general, what we have is, when we consider the legal provisions, we will have baseline conditions. Generally, the baseline conditions are to state that something is obligatory or forbidden, and then we can have other norms that derogate, so they derogate, so essentially they provide exceptions to the baseline conditions, and then essentially they specify that something is permitted. So here we consider an explicit permission when we have specific rules that explicitly make something permitted as a derogation to an obligation or a prohibition. Now, but however, we have another notion of permission, and then we can say that something is implicitly permitted if we fail to derive a prohibition. Or, well, here we can consider that there will be a couple of cases, and then one of the situations is then, well, where there are no explicit conditions to make something forbidden, but also we will see there is another case. Okay, now, here we will just consider the basic definition of permission. Something is permitted if we fail to derive a prohibition for it. Now, here we have to consider the two cases as before. We can say one case where we fail to derive, we fail to establish that something is forbidden, we have a derogation, so essentially we apply an exception. The other case is, well, we are not able to derive, and essentially there will be two cases. Now, one case where we fail is because there are no explicit norms making something forbidden. So essentially, the normative system is silent. They don't have any conditions that say that something is forbidden or prohibited. But then there is another case, and then it's the case we're going to consider. So what about if the system, the normative system, has two norms? One norm says that something is obligatory, and the other says that something is forbidden, obligatory not. We have two norms, we have a conflict, and essentially there are no, well, we will have a failure to derive obligation or prohibition. So obligatory not, it's a prohibition. And then essentially, what about if you have those two norms and there are no way to solve the conflict? what should we do? And then this is the case where we fail to derive an obligation or prohibition. Okay, so let us consider the example. Let's say, well, we suppose that we have a normative system where we have one rule that makes something obligatory and something is forbidden. So here we have the example. So essentially, if you are giving a presentation right after lunch, well, you should avoid, so you have the prohibition to present something technical. However, if you do a presentation for a mosaic project, then essentially, well, mosaic is a very theoretical project, very, very advanced, so you have to give a technical presentation. So what should I do? Shall I give a technical presentation or should I refrain from giving a technical presentation? Okay, so essentially the question we have is that now, what are the conclusions that are entitled we can obtain from those truths? And essentially, now we are not have ex falso quod libet. So essentially we have, but we don't also have, and we want to avoid the ex falso nihil. What should we do? So we want to obtain something. What should we obtain? And then essentially this is what we're going to do after. Now, here the issue is, now, am I permitted to give a technical presentation or not? So here I have the conflict, but is this permission entailed from the two norms? Okay, so let me have a small, let me go back to the background, and then let me go, let's say, kind of very crash course on legal theory. And then essentially, what I want to consider is what are called the principles of legalities. And essentially, a set of principles. And again, here I'm going to take the presentation and the ideas presented by Fuller, again, one of the influential legal philosophers and legal theorists, who propose 7 principles. And okay, the other principles are not relevant for what I want to discuss. And essentially, what we want to see is when a legal system is legal, and then essentially it's some set of consistency conditions about what legal system should be about and what are the conditions inside that. Okay, first of all, our first condition is that if you have a legal system, we have to consider the norms that are explicitly given. So if something is not written in the legal system in somewhere, essentially probably we should not consider. So we should be aware of what are the norms. Now, the other condition is that, well, when you have a set of norms, essentially they should be forward-looking. In general, it's not meaningful. It's, let's say, it's not plausible, and essentially it's not a good idea to have laws that apply retroactively. So essentially, when you want to know what you have to do, essentially you want to know what looking at the future, not what you have done in the past. And essentially, when you look, essentially this should guide and not to tell, oh, you should have done something different. Now, then one of the other principles essentially is that then, well, when you write the norms, so when you promulgate the norms, those norms should be written without ambiguity, and then essentially we should avoid punishment or inconsistencies. And then essentially what you have to do, we should avoid, let's say, unfair enforcement. And then essentially when a judge takes some decision, essentially those decisions should be consistent, they should be applied in the same way, and then essentially we should not have ad hoc decisions. And then essentially what you have to do, and it's related, then essentially laws must avoid contradiction. So we should not have norms where we have something that's obligatory and forbidden at the same time, or there are ways to resolve them. And essentially we should not conclude, even if we have those two norms, we should not conclude that something is obligatory and forbidden at the same time. Otherwise, essentially, we will have some other problems. And then also, well, essentially, what is given in the norms should be possible to achieve, and essentially should not be about impossible. Okay, let's see if we take essentially the problems we have seen before. So if we consider situations where we have one norm saying that something is obligatory, that something and another that saying something is forbidden, let's see how we can proceed and how to reason about them based on those principles here. Okay, so we have the two rules. So essentially, one rule is for obligatory A, the other rule says that P is forbidden, and then essentially we have no clear way to solve this conflict. So in general, legal systems have many principles to solve conflict, but what about if there are some situations where there are no clear, obvious principles, ways, mechanisms, whatever, to solve the particular conflict? What are the conclusions? Okay, let's see. Let's do a systematic approach and let's see what are the possibilities, and then let's discuss them. Okay, the first one is okay. We get that something is obligatory and something is forbidden. However, if we derive this, we violated the principle of consistency because we have a contradiction. So no matter what, I'm going to be punished because if I follow this rule, I will violate the other and the other way around. So probably this is not a good solution. Okay, now, what about if I go for one of the two? So I toss a coin and then I'll go for one way, or I just consider the two options. Now, here again, if I use this particular approach and I say, okay, I have one of the two, but not the other, then essentially, well, we can argue that we're going to violate the principle of clarity because essentially just looking at the norms, I should know how to behave. So essentially, I should know in advance what will be the decision of a judge, and typically it's not the case. And essentially, first, we're going to violate the principle of clarity. And then essentially, if we go for one of the two, where there is no clear way, there is no well-defined principle on how to solve, then essentially, we are going to have an ad hoc decision. Now, the other thing is, okay, if we look also at the temporal aspect, so how do I know that the judge is going to choose one of the two? So essentially, the judge is going to apply one particular way to solve the conflict, but in a retroactive way, because it was not available to me when I was doing a particular action. So apparently, this is not a good solution. So essentially, we cannot either of the two. Okay, well, so what about this? Okay, let's go for the nil approach. So I don't conclude any of the two. That will be another option. So probably this will be I'd say probably the best of the three options. So essentially, I fail to derive, I fail to conclude, I fail to assert that P was obligatory, and I fail to assert that not P was obligatory. And it's here. Now, what you have to do, well, what about permissions? So permission, it as we define, it's that we fail to derive an obligation or provision to the contrary. So what are the permissions entailed by those two norms? Okay, now, let us consider this equation. So let us suppose that we have an additional rule. And this rule says, well, if P was permitted, then X. Doesn't matter what X is. What should we conclude from this? So, of course, we said that option 3 was our preferred option. So essentially, we fail to derive the obligation, we fail to derive the prohibition. But what about the permission? And then what about X? Should we conclude P of X? Should we conclude that P was permitted? And then essentially, if P was permitted, then we should conclude X as well. So possibly this is the idea. Now, okay, now here I'm just using a little bit the notation. It's not too important. This is not the formal part. This is just the intuitive representation and essentially the motivation. Now, essentially, if we have here, it means that we failed to derive the obligation of P. And then essentially we said that when we consider the notion of with permission, the with permission it means that we have this failure. Now, I'm playing a little bit with the symbols, but essentially, the notion that not deriving obligatory P, it's a meta notion. It's not a notion in the object language. It's a meta expression. In most logical systems, I'm not able to set up something it's not provable. Well, there are some exceptions, but this is not the case here. Now, what we can do, we can just introduce a new operator. So essentially, we introduce the negation as failure operator, which is widely used in logic programming and similar approaches. And essentially, what we have, if we introduce the negation as failure operator, then that will be an element in the object language. And essentially, we can speak and we can derive and we can propose conditions. And essentially, this is the language counterpart of the meta expression of this. Okay, now, if we want to do, essentially, we said if we fail to derive the obligation, then essentially we have a with permission. So what we can do, we can introduce the Deontic operator of with permission, and then essentially this will be the language assertion in a kind of Deontic language of the meta language assertion that we fail to derive the obligation. Okay, now, so essentially this will be what we get at the end. So essentially, with permission, it's just the negation as failure of the obligation. Good. Now, do you like the notion of with permission? Yes. Good. If you like, yes, no problem whatsoever. No, you don't like. Okay, good. Now, here, let us consider whether the two following sentences are meaningful, just in the natural language. So, what about this? Provided that P is not obligatory, or it's provided that P is not forbidden. Is this a meaningful language in ordinary language? Yes. Okay, or here we can take what it was proposed by Arthur and Buligin. So Arthur and Buligin were essentially some of the main proponents for the notion of permission in legal theory and from a logical point of view. And then essentially we can say it is false that X, where X is a legislator, has issued a norm to the effect that P is forbidden. Again, is this meaningful or not? It's a valid sentence in language. And essentially, do we agree that those two notions say, okay, we failed to assert that something is forbidden or obligatory. So essentially, we have negation as failure. So if you don't like with permission, again, I just use the term with permission, but then if you don't like the term with permission or the notion of with permission, it just considered as I fail to derive that there is an obligation. And that's it. And essentially, everything else will work fine in the rest of the presentation. Okay, so let me move to argumentation. So how many of you are familiar with formal argumentation, doing like argumentation? Okay, it's more than enough. I'm going to give a very, very quick introduction, and essentially it's graph theory under disguise. And so just use everything you know about graph theory, and then that's it. We just needed to have nodes and arcs between the nodes, and we will speak about that. Good. Okay, now, first of all, we have to introduce the language we want to do. In particular, we want to speak about argumentation and Deontic argumentation. So we're going to see what is the language we're going to use. We are going to see what is the definition of an argument, how to build argument from rules. And then what you have to do, we have a differential argument will be the nodes in your graph. And then we have to explain and define what are the relations between arguments, so which will be the arcs or the edges in a graph. So we're going to take a very simple language. We're going to have atomic propositions and their negations. We're going to have the Deontic operators, obligation, permissions, and with permission. And then essentially we will create the Deontic literals, and essentially a Deontic literal is a literal within the scope of a Deontic operator. And then, well, for the negation of the Deontic operators, essentially we will push it inside. So we will take standard duality between obligation and permission, and we will push inside. Okay, now, what we do, we're going to start from the notion of a rule, and essentially it's what we're going to have. A rule is an if-then expression, where the if part is the condition of applicability of the rule, and then the conclusion, then part, it's the effect. And then what we are going to have is the conditions A1 to AN in the condition of applicability in the antecedent. We're going to allow for other literals or Deontic literals. And then for the conclusion, essentially, we can distinguish whether it's a Deontic literal or a literal. Now, we will going to have a restriction on the rules. We are not going to allow to have a with permission as a conclusion. Because if we have, then essentially it will not be a with permission because we're going to have an explicit rule for a permission. And essentially it will be a strong permission. Okay, now arguments then will be built from rules. And now here we have a problem. Because if a with permission, it's we are going to have a with permission when, well, there are no rules for permission. How can we build an argument for a with permission if we don't have rules for with permissions? So this is the first problem we have to do. And then essentially what we're going to do, we are going to create, let's say, artificial or imaginary arguments for that. Now, the other problem is this, because, as I said, we're going to have two cases where we have with permission. The first is where there are no rules for it, or we have the with permission because we have one rule for obligatory P and the other rule for forbidden. And essentially, what we have to do is then the argument, it's not an argument, but it will be a meta-argument. And again, we cannot build meta-arguments from rules. So essentially, what we have to do, as I said, we have to create those artificial arguments. Okay, so what we're going to do, we are going to look at the complex Deontic argumentation plane. And then essentially, what we're going to have, let's say, normal argument, but though in particular, we're going to have imaginary arguments. So what we do, for every literal, so for every atomic proposition or its negation, we're going to create one argument for it. And then this argument will be with permission of the literal. And then we call this an argument as a subargument. The conclusion will be the permission, and then let's forget about all the part about subargument that it will be needed for the technical development and to prove all the results, but it's not needed for what I want to present today. Okay, now, then again, we have to consider what will be the normal situation. So typically, we're going to have facts and rules, and essentially every fact will be an argument. A fact will be just a literal, so an atomic proposition of the negation. It's considered to be true in a particular situation. The conclusions will be itself, and again, the subargument will be the argument itself. Okay, then the other things is, well, we want to concatenate rules, and then essentially we want to build argument from rules. And essentially, the conditions we have is that, well, we are going to have an argument with this form, A1 to AN C, if there is a rule where we have that for each literal or Deontic literal in the antecedent of the rule, we have an argument for it. And again, the conclusion will be the conclusion, and then essentially we will add this new argument to all the sub-arguments of the already existing sub-arguments. the final condition, and this is about the Deontic properties. And here what we want to do, we want to create another argument. So every time we have an argument for an obligation, so essentially we have an argument B, and B essentially the conclusion of the argument will be that something is obligatory. Then we create another argument where we have in the if part of the argument, and then the conclusions will be permitted literal. So essentially this means obligatory implies permission. This corresponds to the axiom D of standard Deontic logic. Okay, this is imaginary, and those will be the natural arguments. Okay, now, so here we have how to build our nodes in the graph. Now what we have to do, we have to specify what are the relationships between the arguments. And in argumentations, we speak about the attack relation. Then we say that an argument A attacks an argument B, and we will have some conditions. So one case, it's then every imaginary argument is attacked by an argument whose conclusion is the opposite, the obligation of the opposite. So if you have with permitted L and you have an argument for obligatory L, argument A will attack argument. Now, the other conditions, and then essentially this will be the normal condition. So an argument A attacks an argument B if there is a sub-argument of B such that the conclusion of the sub-argument and the conclusion of the attacking argument are the complement of each other, or are the negation of each other. Okay, this condition says, okay, now, again, we will consider that an argument A attacks an argument B if the argument A is for obligation, not L, and then there is a sub-argument of the attack argument, whose conclusion is either obligatory L or permitted L. So obligatory implies attacks any argument where we have obligatory or permitted the opposite. The final conclusion is, what about if we have that the argument A it's for a permission? This argument will only attack argument having a sub-argument for the opposite obligation. So if we have two rules, one for permitted P and the other for permitted not P, those two arguments do not attack each other. If we have an argument for obligation, it will attack an argument where we have the obligation for the opposite of the permission of the opposite. If you have an argument for a permission, the argument for the permissions will attack an argument for an obligation of the opposite. And again, every imaginary argument is attacked by an argument for the obligation. And then it's because we want to have the negation statement. Okay, so let us consider this example to clarify the notion. So here we have those 6 rules. From those 6 rules, we can compose those arguments. Here, I just have the imaginary argument which are relevant. So I didn't consider S and T, so it would be relevant for this notion. Then essentially we can see if we have a simple rule, we can create the arguments. If we can concatenate the rules, so essentially here I can have R1, it's for the obligation. The obligation is the antecedent of R3, so I can concatenate and create another argument here. And then, I have also the argument for the permission, because this argument was for the obligation. And also we have, well, every time I have an argument for the obligation, I create another argument where I have that argument in the if part, and then the conclusion is permitted. And yeah, and essentially that's it. So final part is also to consider what are the attacks. So let's just consider one particular situation. What we have, this argument here attacks the argument for the opposite. There is obligation and obligation, so there will be an attack. It will attack an argument for the permission, obligatory P, and here we have permitted not P, so it will be attacked, and also it will attack the imaginary argument for me. And also we can consider the other one, but again, hopefully you will trust me that there are no typos and the computation properly. Okay, so this is the general framework we are going to create. So essentially, we have created an argumentation framework, and then we have to see, and we are going to look quickly at what are the typical semantics, the standard semantics for argumentation. In particular, we are going to consider the two most popular semantics, grounded and stable semantics. Okay, so the idea was proposed by Dung, and the idea is to consider a set of arguments, and essentially what we are going to consider is, well, what are the relationships between the arguments, and we want to build a set of arguments that it's able to defend itself against all possible attacks. So first of all, we're going to have consider sets of arguments that are conflict-free. So I take an argument and there are no arguments attacking each other inside that particular set of arguments. Then, okay, let's say I have a set of arguments. What are the arguments compatible with this set of arguments? So what are the arguments that are acceptable? And then the arguments that are acceptable are the arguments such that if the argument X is attacked by another argument, the set S is able to defend. It means the set S has an argument Z, and Z it's going to attack the argument attacking X. Okay, then this is the very, very standard construction. So first of all, we want to consider when a set is admissible, and then essentially what we want to do is, okay, we try to build the set of all admissible arguments. Essentially, we try to insert as many arguments as possible. So arguments that are not in conflict with the other argument inside. And essentially, at the end, we're going to get to the notion of complete extensions. And essentially, we try to have all arguments that are able to defend themselves. Then essentially, we consider the two most common and most used semantics of the grounded extensions. And essentially, the grounded extension is the minimal complete extension. So essentially, we consider what is the real core of the arguments, all the arguments. And essentially, one of the properties of the grounded extensions are it's split. For every set of arguments, there is only one grounded extension in my identity. Then essentially for the stable extensions, essentially what we want to do, we want to have to consider essentially the maximal, and essentially it is possible to have multiple of them. So essentially for the stable extensions, we start if there are conflicting arguments in one extension, so we're going to have one of them. We're going to have another extension where we're going to have the other one, and so on. So this table essentially it will be we're going to have in general, if there are conflicts, we're going to have multiple stable extensions. There are some other definitions, but again, I'm not going to go in the other definition of those. So this is skeptical, and essentially this is credulous, because here we're going to have only one, and here there will be potentially many, and essentially there will be. Now, here when we consider the argumentation, essentially we just look at the argument. We are not going to look at how the arguments are built. So how the argument is built and so on will give us to consider the acceptance condition and how to build the extensions. But then essentially what we have to do, we have to consider what are the arguments we're going to consider. So an argument is justified or skeptically justified if it is in the intersection in all the set of extensions for that particular argument, And then what we can do, we can lift the definition just to the conclusion. So a conclusion is justified if it is a conclusion of a justified argument. So first we build a set of arguments, we look at the conclusions, and then essentially the extensions, and we were going to consider essentially we can interplay between the extensions of a set of arguments and the extensions of a set of conclusions. And for the conclusion, we take the conclusion of the justified arguments. Okay. Now, here we just to consider, this is part of the technical definition. Now, I say, okay, what about if we have a theory, so a set of rules, and then this theory, we say that this theory is conflictual if essentially if there are two rules, one for an obligation and the other for the prohibition, and then for those two rules, we are going to have arguments for the antecedents. For all the elements in the antecedent, we are going to have arguments for them. So essentially it means, well, potentially we are going to be able to conclude obligatory C, and potentially we are able to conclude obligatory not C. And C, okay, will be the conflictual literal. Okay, now this is the first main result. Now, if we have a conflictual theory, so a theory where there are the two rules, one for obligatory L, the other for forbidden L, and then those essentially they are arguments leading to them, then essentially it's not possible to prove, it's not possible to have the weakly prohibited P and weakly prohibited not P, L are justified conclusions under the grounded and stable semantics. So essentially stable and grounded semantics are not able to prove that something is weakly permitted if we have a conflictual theory. Okay, let's see the reason. So this is the simplest conflictual theory you can build. Those are the arguments we are going to get from those theories. So there will be arguments corresponding directly to them. There will be the two imaginary arguments, and there will be the argument from obligation to permission. Okay, then simply we can say that, well, this imaginary argument is attacked by this one. This argument is attacked by this one. This argument is attacked by this one. And then also we can see that we can reverse. So this argument attacks this one. This argument attacks this one. This argument attacks this one. And essentially this is here. So essentially what we can do, if we consider what are the admissible extensions, we're going to have that, well, this argument here is A1, A3, essentially they are able to defend themselves against the attack. So A1 attacks A2, so essentially it's able to defend itself. A3 is attacked by A2, but essentially A2 is attacked by A1, so it defends. And also A2 attacks A1, I1, but A1 defends it. So those will be the maximal extensions. And then you can see that the two maximal conflict-free extensions are destroyed. So essentially, there are no arguments in common. And essentially, with what we can see in particular, we can see that the arguments I1 and I2 are not in the intersection, well, intersection is empty, so no argument is there. So it means that there is no argument, there is no justified arguments where we have the conclusion it's with permission only and with permissions not. So essentially, it's not possible to do. So it means stable semantics and grounded semantics are not able to capture, to model with permissions if we have a conflict for that particular literal. And those are the two most common semantics. Practically every single paper on argumentation, they use either grounded semantics or stable semantics. So essentially, they're not able to do it. But we have with permission. So what should we do? Okay, what you have to do is to create a new semantics. and then essentially we are going to see how to do and how to modify the construction. Now, what we're going to do, we are going to use exactly the same argumentation framework as before. So the definition of argument is exactly as the same. And what you have to do is just to modify the definition of attacks and so on. So here what you have to do, we have to introduce two additional notions. And then essentially the first notion is to say now, one argument is supported. What is the idea of support? So an argument is supported by a set of arguments if all the proper subarguments are in the set. So essentially, this set essentially enables the conclusion of the conclusion of the argument. So the conclusion of the argument A essentially is supported by all the other subarguments. So essentially, we can build and essentially say, I've already asserted all the sub-elements, and essentially I just have to do the final step. Now, the other notion is kind of the opposite. So instead of support, I say, now, when I can stop an argument, when I can stop a conclusion, well, and I'm not just considering the notion of attack, I think this will be needed to define the notion of attack. And essentially, we introduce the notion of undercut. And undercut, it means now I'm able to disprove some of the premises of the argument. So there is an argument P. Remember, the argument will be formed by a rule. The rule will have the conclusion, and then essentially we're going to have the conditions in the antecedent. And then it means that we undercut, an argument undercut, if I have the set is able to go to the final step, and the final step essentially attacks a proper natural subargument of B. Here the key point is natural, so it's not going to do the for an imaginary, just the natural, so not the permission. Okay, let's see the example here. So let us suppose we have those rules here. So as you can see, here I can form one chain of reasoning from R1 and R2 to obtain obligatory B. Here I have essentially this argument here, this rule here. Essentially, it will be triggered. It's possible to apply if we have weak permissions. Essentially, if we have the imaginary argument. This it will be just we can form a chain from this from 5 to 4 to conclude B, and so on. Now let's see the other notion. So now, what are the arguments that are supported by the set? So here there are no premises, so essentially this argument is supported. Here there are no premises, so this argument is supported from the empty set. So essentially, from the empty set, potentially I can prove not B is permitted, and from the empty set, potentially I can prove A. I can assert A. Okay, so that will be the first step. For the second step, essentially, let us consider what are the possible attacks. So here we have that when I combine those two arguments here, I have an argument for obligatory B, so it will attack the imaginary argument which is permitted. And then essentially, well, since I will attack the argument 3. Also, this will be an argument for the obligation, so it will attack that one. And okay, this argument, okay, will attack also that one, but it's not needed for what I need in this example, but also in this direction, this argument will attack that other argument there. Okay, now, so we said that the arguments that are supported by the empty set are these and that. So what we do, we have that R2, this argument here, it's supported by this set here. So if I'm able to assert this argument here, then essentially, well, potentially I'm able to assert this one. Now, here I have an argument OB that attacks one of the premises of this argument here, so it undercuts. However, so even this argument here will attack this argument here. This is an imaginary argument, so we'll not say that it undercuts. So undercut essentially, and essentially if you consider the idea is, well, here to undercut, to say this argument is not good, I cannot use it, I have to fail to prove this. While here, I say, oh, I needed just to say that there is a conflict between this conclusion and this conclusion. I don't know which of the two. But here I say, well, this will be stronger by this, but I have to disprove this if I want to go on with that one. And essentially, just to have that it's potentially applicable, it's potentially able to prove the conclusion, it's not enough to say that I failed.
Sorry, can I say something about the example? R2 attacks not B is weakly permitted.
Yes, it attacks. Yes.
Right. So R2 attacks. So I'm referring to the first one.
Yeah.
In your example. Yeah.
Yes.
No, the previous one. The R2 attacks PW, not B.
Yes.
Yeah. So R2 attacks it by itself or in combination with R1?
Oh, well, keep in mind, it's a shortcut here. So R2, it's I combine.
Okay.
I combine.
Because otherwise I would.
Yeah.
Okay.
I didn't say, okay, I have to say A2, which is the argument obtained this and that.
Okay.
So yeah, it's a bit of shortcut.
No, just to understand
Yeah.
because by itself it would.
No.
Okay.
So if you don't have this part here,
yeah,
then essentially this alone will not be an argument.
Okay, good. Okay. Right.
And so it will not be able to attack. So here essentially, well, it's the argument whose last rule is R2.
Okay.
This is the way to read it. Yeah. Also this one, it's the conclusion, not the argument.
Not the argument. Yeah.
So, but then just to make it more simple.
No, I get it.
But yeah, you're right. Okay. Mm-hmm. Okay. Now, this is the first step. Now, in the definition of grounded and stable semantic, we started with acceptable. Here we have to refine the notion of acceptable. And essentially here we have to consider whether we have a natural argument or we have an imaginary argument. So an imaginary argument is acceptable if and only if, well, every argument attacking it is rejected. And we will see the definition of rejected in the next slide. So here what you have to do is to split and to add the definition, and we have to say when an argument is a good argument, so it's able to produce a conclusion, and when an argument is bad, the argument can be thrown away. It's rejected. So we will see what is the definition after, but we should read together. And now what we're going to do here, we are going to consider two sets of arguments. The set of rejected arguments, so the arguments we know are not good, and the arguments that are accepted, so the arguments that we know are good. So, as we said before, we are going to see, we started with from the empty, as we will see in 2 slides, we're going to start from the empty set, and then essentially we're going to be the set of acceptable and rejected arguments. So, now, for an imaginary argument, to say that the imaginary argument is good, we have to say that the argument attacking it, so the obligation argument for the opposite are rejected. So it means we show they failed. That is what it means by rejected. Why? If we have to consider a natural argument, well, a natural argument, what you have to do is say, okay, now let us consider the argument attacking it. Now, the argument attacking it must be lost undercut by the good arguments. Or, well, the other case, the argument attacking is rejected. So that is within a simple case. But also, if it is just, we are not able to prove it because some of the premises were not supported. So essentially, we are not able to have a positive assertion of the antecedent, then we discard it, and it's not good. Now, here we can consider the notion of rejected, and essentially there is a strong duality between the definition of acceptable and rejected. essentially they are the dual of each other. So an imaginary argument is rejected, and again, we have the set of bad arguments and the set of good arguments. And essentially, imaginary argument is rejected if it is attacked by a good argument. It's attacked by an argument that will prove it's good. So the imaginary argument means I fail for the opposite, and I say, no, I have something for the opposite. So I fail to fail. And then, well, a natural argument is rejected. Well, if there is one of the sub-argument is rejected, so essentially, well, I already discarded some of the elements inside it, some of the sub-element of it, or there is an argument which is a good argument, and then that argument is supported. So potentially it's a good line, not that it's just applicable. So if I have a conflict, I don't want to prove the conflict unless I'm able to throw away one of the two points. Okay, now this is the fixed point construction. So the extension will be based on the set of good justified arguments and rejected arguments. And essentially here we start from the empty set, and then essentially we just build it's just a standard fixed point constructions. We start from the empty set, just a minor technical point. The semantic starts from 1, not from the empty set, but again, this is for a technical reason. And then essentially, well, at every step, what I do, I consider the set of justified argument is the set that are acceptable with respect to the previous steps. And the set of rejected argument is the steps that can be rejected based on the argument that I've established at the previous steps. And then this will be just a standard fixed point constructions. We take the union of all of them. Then, well, again, it's to prove that the construction it's monotonic, so the fixed point exists, and then it's unique because it's standard Napster construction.
Sorry, also just curiosity, it looks like the closure ordinal is omega.
Pardon?
It looks like the closure ordinal is omega.
Yes.
Right.
Yeah. Again, you can go for omega, and then if you want to go to the transfinite again, you can do whatever.
No, but I mean, the closure ordinal, like the least ordinal where you reach a fixed point.
Yes.
It has to be omega.
Well, definitely, yes.
Right, okay.
In the worst case, yes.
Yes.
Yeah. Well, yes. Typically, you reach much early, but yes.
Right. If you
have an infinite set, again, it will be omega. Correct. Yeah. Okay. Now this is this. It's now essentially the good argument are the argument we are going to get in the fixed point, and then essentially a conclusion. It will be a good conclusion if it is the conclusion of an argument in the fixed point. Okay. Then I said, well, the extension exists, so it's just the Napster theorem that it's the list fixed point exists, it's unique and well defined. Again, essentially it's practically part of the same proof. And then also, well, this is it's conflict free, so essentially there are no inconsistencies. Again, this part is trivial, that's not. That it's hard. Also, we can say that it's conflict free, so you don't have arguments that attack each other. And then essentially what we have that it's also consistent, it means that, well, no argument is at the same time acceptable and rejected. So essentially, one is about to prove that when you go to the set of justified arguments, no conflict, there are no internal conflicts. And essentially, well, if you throw away an argument, the argument that it's not a good argument. So no good argument, it's a bad argument in the other way around. So it seems it behaves properly. Now, what about if we have a conflictual theory? Well, if we have a conflictual theory, those conclusions with permission L and with permission not L are justified. Again, that will be the simple constructions as before. We have exactly the same argument as before. I'll throw away the argument with the permissions because again, they're not relevant for the example here. And then essentially what you can see, so those two arguments are supported by the empty set, they have empty antecedent, and then essentially they attack each other. This means, so this argument will attack that one, but this argument will undercut this argument here, and the other way around. And then essentially we have that the two arguments are attacked, but essentially will be, but the argument attacking are rejected, and essentially, so we fail to derive obligation A and obligation not A. So the only two standing arguments will be this argument and that argument, and essentially we will have it will be in the extensions, I think from the second step, and then essentially it will be justified. Okay, now, so essentially here we started to say that, well, the modeling, the failure to derive an obligation is meaningful in illegal theory and also relevant. Also, well, we have gave a couple of examples. Again, if you want, we can call with permission. If you don't like, don't call with permission, just fail to derive. And then also we prove that grounded semantics and stable semantics are not able to model that particular notion. The new semantics, it's able to do it. Now, what you have to do in the future is, well, what about if we want to have the two semantics together? Now, the two semantics, they correspond to slightly different legal principles. So, in legal reasoning, you have the notion of the burden of proof. So, essentially, how you prove something. And essentially, when we consider the grounded semantics, and just consider the situation where we have only one single extension, not multiple extensions, then grounded semantics correspond to the beyond reasonable doubt proof standard. While the other semantics, the semantic I presented today, correspond to a slightly different standard, which is essentially preponderance of evidence or the best evidence or whatever. And essentially, it is possible to give an example of situations where you want to have both of them. So the next or past challenge, and I'll explain why it's both next and past. It's well, how to do integrate the two semantics. So the next challenge is how to do integrate the semantics using argumentation. I know that probably don't do argumentation because it will be very, very messy. And essentially, is it possible to capture the two notions? Also, the two semantics correspond to different intuition of a non-monotonic reasoning. So grounded semantic corresponds to ambiguity propagation. So you have an ambiguity, so essentially there is a conflict. So everything following from the conflict essentially will be not just justified. You're not going to assert it. While the other semantic is ambiguity blocking. So you reach a conflict, so you throw away, but then essentially conflict and other conclusion following after will follow the normal path. So the conflict will say it's not true, it's false, it's not asserted, but essentially will not have influence on other parts. So essentially, how do we combine ambiguity blocking and ambiguity propagation? It's very conflicting in the same mechanism. So we develop a logic where we are able to do that. Well, we want to see what it's possible to do with argumentation and to combine those semantics and combine semantics. Okay, that's it, and thank you for listening so far, and open to take some questions.